So before we proceed to the second task, we have to conclude that the graph will show a larger resistance, rather, if we have a larger resistance of the value of a resistor, the supply voltage will be larger in value too, in order to turn the SCR, turn on rather the SCR, and vice versa. So for our task 2, we are required to set the values in our circuit, such as the battery to 9 volts, the potentiometer 1 to 100K max, then the 50K max for potentiometer 2 with the 50K resistance, and then for the LDR, we are supposed to set it to 650, and the R3 is to be 50K. So for the potentiometer 1, additionally, we have to set it to 30% setting. So we have to first connect our wires, which is now shown here. So before we run the simulation, we have to set our lux to 650. It's 50. Yeah. R1. So before we run, after we run, we should change this to 650 lux as said in the problem, and then we have to change this to 30% said in the problem. So our good digital multimeter will reflect a value of 2.34 volts. So the bottom line here is we need to balance our circuit in order to produce our ideal value, which is 0, which means our circuit will be balanced. So in order to display that desired value, we have to first is to we will use the trial and error method. So first things first, we have to set our potentiometer here. We have getting to 30%. Now we have to calibrate our potentiometer number 2. So what will happen if we decrease our value here? It doesn't decrease in value because it reflects that there's an increase in our volts. And as we turn it up, it also increases our output, which from 2 volts, approximately 2 volts, it became 3 volts. So now, what if we decrease our percentage here? So if we decrease it is closing into 0. From 3, it became to 1 in 28%, and then we have to decrease it more. And along the lines of 14 to 14.33 to 15, we have the decimal here. So what if we input a number with a decimal, which will reflect our desired value, which is the 0 value. So if we put the certain value here, now our potentiometer, 3.46 or 3, we can see now that we have a 0.00 or 0 volts to be approximate. So now, with that, we have balanced our circuit, which is required for our second task. That is all for me. Thank you for watching.